Alright, so this is the reactions of alkenes, and this is really important. Judging from past papers, they ask you a hell of a load of questions about this. So you've really got to know it quite well, otherwise you'll lose loads and loads of marks, end up failing your chemistry exam, get kicked out of your home, end up living on the streets, and it's not going to be good basically. So you've really got to know what these reactions are and the mechanisms involved in them. And some of the mechanisms, what they do is they use curly arrows, and a curly arrow shows the direction an electron is travelling in. So we'll go through one of those first. So we're going to go through BR2. There's 4, you need to know in total. BR2 is probably the most difficult one to learn. So we'll start with the worst. So this is all to do with ethene. Obviously it can be a more complicated molecule. Let's just concentrate on ethene for now. And I'm going to have my BR2. Now, BR2, each BR has got an equal electronegativity, so usually this wouldn't be a polar bond. The electrons would be smack bang in the middle. But, as my BR2 approaches this double bond, the 4 electrons in the double bond push the electrons here away from this top BR, because like charges repel and they both have negative charges. So these 4 electrons are pushing the electrons down. So rather than the electrons being in the middle of the bond, they get pushed down here, like that. Now you don't have to draw that in the exam, that's just to show you roughly where the electrons are. So as they're closer to this bromine is going to have a negative dipole because of the electron's negative charge, leaving this one with a positive dipole. Okay? So, as this is a positive dipole, this is now an electrophile. It wants electrons. It's going to nick some electrons from somewhere. And this is quite a good place to get them. We've got 4 electrons in a very small space. So what happens is 2 electrons go from this bond to the bromine. And I show that with a curly arrow. If I make my curly arrow come from the carbon, nil point. If I make it go from the double bond to a bit of empty space here, nil point. If I make it go from the double bond to that bond, again, you get nothing for it. You've got to make it go from that bond to the bromine, because that's where the electrons are travelling from, and that's where they're travelling to. And also, the electrons from this bond go to that bromine there. And what that leaves us with is my BR, I'm assuming it was this carbon which made the bond with it, and since this carbon has now lost its electron from this bond, it will now have a positive charge. And I've got this bromine down here, which has got an extra electron, so that's going to have a negative charge. And a lone pair of electrons. So it's actually going to have quite a few lone pairs of electrons. And so what we've got now is a carbon with a positive charge. Now another name for something with a positive charge is a cation. So we've got a carbon, which is a cation. So we call this molecule here a carbocation. And its full name is a carbocation intermediate. Because it's not what you start off with, it's not what you end up with, it's the thing in the middle, so it's the intermediate. And then what happens is my BR, because it's now a nucleophile, because it has a negative charge, attacks the carbon with the positive charge, opposite charges attract, and it will join to it, it'll make a chemical bond. So we end up with, I don't know if you can see this on the video, we end up with this thing here, with both my bromines attached to each of the carbons. I've got one attached to each carbon. Now you get 3 marks of this. You get 1 mark for drawing in this arrow, you get a 2nd mark for drawing in your dipoles and this curly arrow, and you get your 3rd mark for drawing in this curly arrow. That's assuming they draw the molecules out for you. If they don't, you could get a 4th mark for the final product or for naming the final products. So there's quite a few marks involved there. And that's the reaction of bromine with, in this case, ethene, but it works the same for any halogen, any alkene.